Okay, welcome. In this lesson, we're going to do some more practice with while loops and talk about some common loop algorithms you might be faced with that loops are really a good tool for solving. So one common looping algorithm you might use is to determine the smallest or largest number from a bunch of numbers that the user enters, right? So maybe you're asking the user to enter in a bunch of their test scores, and this is going to print some statistics about all of their tests, like what was their lowest score, what was their highest score, what was the average, and so forth. And so you really need to kind of like do a loop. Continue to ask for questions continue to ask for scores until they're done, and at the end you'd print out what their smallest score was. So you've got to keep track of what their smallest is somehow. It's a common algorithm. So for example, here's a bunch of puppies. They're like little wiener dogs, and you want to ask the question, how small is the smallest dog, right? So here's some pseudocode to kind of get us started thinking about how you would find the smallest from a series of user inputs. So whatever they're typing, they're going to type a number in to begin with. And so your smallest is, you can just kind of assume that the smallest is whatever their first number is. If they only type one number in, then you're done. It is the smallest. Because we kind of need a benchmark. Everything else is going to get compared to what the smallest is, and the smallest for the first number will be the first number. And then you got a loop, right? You got to keep getting numbers. So while there are more numbers for them to type in, then you compare it to whatever your smallest value is currently. So you'll say, if this number that you just got is smaller than what your smallest is, you update smallest to that number, right? So you're going to change the smallest to the new number that is now the new smallest number. So for example, if I'm looking over these doggies, if the first dog is the biggest dog, then he's the smallest one, and then we get the next dog and we say, oh no, this one's smaller, so we're going to change smallest to this one. And then we look at the third dog and we're like, hey, the third dog is actually the smallest one. It's smaller than the second dog, which is the current smallest. And so the third dog ends up being the smallest one. So this loop runs. We got to keep getting numbers. And then once you're done, once you've gotten all the numbers, at the end of the loop, you're guaranteed to have the smallest holding the smallest number. So that's the basic algorithm for determining the smallest out of a series of numbers. So that's the pseudocode, and let's see what this looks like in Java. So the first thing, we're getting a number, and we're getting it from input. And then we're setting a smallest variable. We're setting a variable, we're going to call it smallest, to whatever that number is. Now we have to have some counter, some test to some way for the user to stop entering numbers in. So a common thing is, say you're expecting all your numbers to be positive numbers. Like, for example, weights of dogs, they're all positive numbers. Test scores, they're all positive numbers, hopefully. It'd be weird to get a negative test score. So you're going to loop as long as they're passing you positive inputs. And as soon as they give you a negative input, we quit the loop and we jump out. So that's why this while loop condition is checking for their number to be more than 0. So then we do the comparison, right? So now we compare. Is the number we're looking at smaller than the smallest number currently? And if it is, we update smallest to equal that number. Close the curly brace, and then we get the next number and put it into that number variable. So input gets stored into number. If the number is a negative number or 0, then we quit the loop and we're done. So that would be an example of finding the smallest from a bunch of user entered in numbers. We can see what that looks like in action. Let me open up IntelliJ and we'll take a look. Okay, so here we've got an IntelliJ program set up where we have a scanner. We prompt the user to enter positive numbers, and we get that. This is the effectively the code we had just written. Int number equals input.nextInt. Set smallest to that number. Loop as long as our numbers are positive. And then at the end of this, we print out what smallest is. So we'll go ahead and give this a run. The only thing I added in here were some prompts to make it a little bit less confusing. So let's go ahead and give this a run, and we'll see what we get. So we'll enter a positive number. We can start off with 10. We can start adding 3. So far, what is our smallest? It's 3. We could do a 7. And then we'd quit by typing 0. And look, there's smallest. Smallest is 3. So this was keeping track of the smallest number, which was the second number we typed in, 3. Okay. If we want, we can set a breakpoint and actually dive into this in a little bit more detail. But I might do that in another video, where actually we can keep track of these variables, smallest and number, and see them change dynamically in the debugger. Okay, so that's a common looping algorithm. Find the smallest or largest. How would you change the code so that this determines the largest number? So I'll let you think about how that would change. It's not too different. It's basically the same algorithm. You assume the first number is the biggest number, and then if you find a bigger number, you just change that to, you update biggest to that number if there's a bigger number, right? So if we did it for the doggies, you know, if we started with this dog, we'd say, hey, you're the biggest dog because we haven't seen any other dogs. Hey, you're not bigger than our biggest dog, so biggest is still the first dog. Hey, you're not bigger than our biggest dog, so biggest is still the first dog, and we're done. Okay? All right. Here's another common looping algorithm. You might want to add up all these numbers, right? So like instead of figuring out what's the smallest number that the user prints out, then what would be the biggest, or excuse me, what would be the sum of all the numbers that they type in? So, you know, like how much do all these puppies weigh? You know, like look, there's so many golden retriever puppies, and they probably weigh, you know, I don't know, 3 or I don't know, 5 pounds, maybe 6 pounds. I have no idea how much a puppy weighs, but you know, you would ask the user to type in, you know, how much does puppy weigh? The first puppy weigh? How much does the second puppy weigh? The third puppy, and so forth, until they're, you know, enter in a 0 or a negative number, and then the program stops and it prints out how much the total puppies are. And so a pseudocode for this is similar. Except now we're starting our sum off at 0, because if there's no puppies, then the total is going to be 0. There's no weight, right? And while there are puppies to weigh, right, while there are numbers to input, then we just get that number and we add it to the sum, right? So the first puppy we weigh, we say, okay, 5 pounds, add that to the sum. So sum is now 5, and then we get the next puppy, so we weigh the next puppy. This puppy is a little heavier, it weighs 6 pounds, so we're going to add it to our total, and now sum is going to be 11. And so we just loop while there are numbers, adding each number to the sum, adding each number to the sum, getting to the next number, getting to the next number, and then at the end we've got the sum. So in Java, this is what it looks like. We start our sum variable to 0. So sum starts off at 0. We'll get the next number from user input, or the first number rather. Sorry, this is the first number from user input. As long as it's a positive number, remember we're looking at weighing puppies or test scores or whatever, so we'd have to change this program around if we're going to let them enter in negative values. It would make it a little trickier to stop this. We use the shorthand sum plus equals number, which is the same as sum equals sum plus number. And then we get the next number from the user. So we'll just keep looping, and then when the number is a negative number, we quit. So that would be our approach to adding all of them up. So we can add that into our program over here pretty easily by just adding another variable, sum equal to 0, and then not only are we updating smallest, we're also updating sum, so we'd add whatever number is to sum each time. So now we can print out the sum. That's out sum plus sum. So everything else is effectively staying the same. We get a number, we start our sum off at 0. While that number is positive, we add it to the sum, and then we get another number from the user. So this gets the next number. If it's positive, we add it to the sum, we get the next number, and we quit once they enter a negative number. So let's go ahead and test this out for a couple of numbers. We could do 10, 3, and 7, or maybe we do 5, 4, 3, and that's good enough. We'll stop. -1. So 3 was the smallest, and if we added those numbers up, 5 plus 4 is 9, plus 3 is 12. Might as well, at this point, just add in the largest one, because why not? So to add the largest, you would add in another variable, int largest. If number is more than largest, then we update largest to number. So that's exactly how you would include the largest in this. So let's go ahead and add largest. Okay, so let's see if that works as intended now. Let's see if we get all three things. 10, 15, 25, and we're done. So the smallest number we entered was 10, the largest number we entered was 25, and the sum of all those numbers was 50. So it's a good way to get some statistics out from the user entered numbers. And in this case, we kind of have our loop stop when they enter something that's not positive. So it stops at 0 and it stops at anything less than that. So I would encourage you to think about maybe how might you use this to, say, compute the average, not just count, not just what's the largest, what's the smallest, and what's the sum, but also what would the average be. And so you need to also count how many numbers they type in. That would also be something you'd have to gather as input from the user. Okay. All right, so here's a little test method for you. Try writing a method called sum 1 to n. So it takes one parameter, an integer, and then returns the sum of the numbers from 1 to n inclusive. So you would add, so say I did sum 1 to n of 5. So if we were to plug in 5, you know, sum 1 to n of 5, then that's going to be 1 plus 2 plus 3 plus 4 plus 5. Okay? So go ahead and think about this a little bit and give it a try. You're going to need a while loop. This one doesn't use user input at all. It's just a method that uses the integer n parameter to know when to stop. Okay? So go ahead and think about this and give it a try, and if you get stuck, you can just play the video and I'll walk through the solution. Okay, so here's the answer. I'll let if you've already given up or you think you have the answer, hopefully you should be able to check it yourself. But here's how I would go ahead and do this. So we need to keep track of a sum. So I got a sum variable, set it to 0, because if we don't have any numbers, we're not adding up any numbers, then we would just return 0. And then we're going to start our numbers off at 1, because that's what we're starting. We're going from 1 to n, including n. And while the number that we're starting at is less than or equal to n, we'll just add it to sum, and then increment that number to the next number in the list. So because we add 1, and then we add 2, and then we add 3, and then we add 4, and then we add 5, and so forth until we get to n. And it's a little bit important to remember that that's less than or equal to. If we don't have the less than or equal to, we'll actually get a slight error. We would get an off by 1 error where we wouldn't add the last number. We would do 1 to 5 exclusive, and so we would miss the last number if we did that. This isn't the only approach you could do. You could have also counted down instead of counting up, because if you start at n and then count down, you would also get all those numbers, 5 plus 4 plus 3 plus 2 plus 1. So how that would work if we counted down would be something like this. So now we would still have the same first line, and instead of int num equals 1, we take this line out, and we would say, instead of while num is less than or equal to n, we'd say while n is greater than or equal to 1. That's what we do. And then we would add n, and we would do n minus minus. And so if we were to, we could change it around, and instead of counting from 1 up to n, we could just count from n down to 1, and we would still get the same result. Okay? So either way you do this would work. All right. Here's another one. So we just did 1 to n. Now write a method sum a to b. So you can kind of use your last one as a starting off point that adds the numbers from a to b inclusive. So, and for this you can assume a is smaller than b. And if a is or smaller than or equal to, and if a is more than b, you'll find out is that it should return 0. That's what it would return in this case. So if b is less than a, or a is more than b, then the method will return 0. Okay? So go ahead and give it a thought and give it a test. And then if you've got it, you can look at my answer in a minute. Okay, so here's the solution that I came up with. Now we have our sum set to 0, because we're starting off by adding a bunch of things, and we want to start off with 0. And so we'll loop as long as the first number is smaller than or equal to the second number. Add whatever a is, and then increment a up to the next number. And that would get all the numbers from a to b inclusive, because we're starting at a, and then we add a on, and we make a go up by 1, and then we add a again, and we make a go up by 1 again, and so forth. And that would give us the sum. Now if you're worried about a being changed after this, well, only the copy of a that's inside this method is changed by this. So we don't have to worry about the fact that a is being changed inside the method. Outside, wherever this was called, a would not be affected by our method sum a to b. So you don't have to worry. So don't worry about this a++. Don't worry about a being changed, because only a copy of a is changed, a copy that's local to this method alone. Okay, here's another one. This is a little bit different, and it's going to require a little similar thinking process, but you're going to have to do some string methods in this. Try to write a method called reverse that takes a string as a parameter and returns the parameter in reverse order. So for example, if I called reverse funny, so I gave it the string funny, then it returns enough, YNNUF, which is funny backwards. So this is another loop problem, because we're going to be looping through the string, and it might be helpful to think about looping from the back of the string to the front. Okay? So as a hint to do this one, I'd start off with an empty string as the answer, much like a sum set to 0. You're starting off with nothing, which is the empty string. Maybe you remember the empty string is just the double quotes with nothing inside of it. And then you just start gluing onto this empty string the last character of your parameter. And you keep getting the last character, or get the last character, and then they get the one that's right before that one, and then get the one that's right before that one, and then stop once you get to 0, to index 0, because the index of the last this character is 0, and the index of this one is length minus 1. So that's how you could kind of start at the end and work your way to the front to get this thing reversed. Now, it's not the only way to do it, and I'll show you another method once you've tried doing it this way. Okay, so pause the video, and then I'll walk through the solution to this. Okay, so here's how one approach to solving it. We start off with our empty string. So this is what I'm going to return. This is what we're going to return, which is empty initially. We start an index counter at the last character's index, right? This is going to equal, for funny, 0, 1, 2, 3, 4. So this would be 4 in the case of funny, and in any other string, this is always going to start at the index is the index of last character. In the string, no matter how long the string is, because we're using string.length to get it. Now, we're going to loop as long as the index is more than or equal to 0, because the last character we want to glue to our answer is the very first character of the parameter string, right? So our last character we're gluing is the f, which is the thing at index 0. So then we're gluing the index character, so the substring that goes from index to index plus 1. So this is the character at index. Character at index. So this is that character. And then we just move our index counter to the left by 1. So we move it down 1 each time. And so this will eventually stop once index gets to 0. And then we glue the first character to the end. And then we're done because index becomes -1. And we quit the loop and return the result. So there's another approach to doing this. First, let's go ahead and program this one up. We're going to call this reverse. So public static string reverse string stir. So we're going to take our string and reverse it. String results equals the empty string, and I'm going to return results right away so that I don't have compiler errors. Now we'll loop, so we can get index equals stir.length minus 1 while while index is greater than or equal to 0. We glue to result stir.substring index plus 1, which is the character at position index. And then we just have to decrement our index counter down so that it gets closer and closer to 0. So let's look at the result of reversing some stuff. So reverse, we'll say the original, what would be a fun word to reverse? Well, we'll just do funny reversed plus reverse funny. So we'll try that. So there we go. So funny and then reversed is enough. And let's do another one. Original, Madam, I'm Adam. And then reversed, Madam, I'm Adam. So there we go. Madam, I'm Adam. Reversed, mad, I, madam. This is a palindrome, meaning it's the same forwards as it is backwards if you were to read it out. Madam, I'm Adam. Okay, so that's an example of reversed in action. Okay, so another way we could have done this too, here's another strategy for doing this that doesn't use the index as a counter. Instead, it just glues the last letter of string and then takes the substring of string of str, of stir, and just throws away the last letter. So let's look at that other implementation of how you could do this. So results equals, we'll start off with our empty string. We're going to say while stir.length is greater than 0. So while there's letters left in the string, stir, we're going to glue the last letter, which is stir.length length minus 1. So this is the last letter. We're going to glue it to result, and then we're going to update stir to everything but the last letter. 0, stir.length minus 1. So now stir gets shrunk, so this cuts the last letter off of stir each time, making stir get smaller and smaller and smaller. So this loops as long as there's letters left. As long as there are letters left in stir. Glue the last letter to result, and this would also reverse it. So we should see no change in our results. Funny and then reversed is enough. Madam, I'm Adam is still Madam, I'm Adam because it's a palindrome. Okay, so this would be another approach to doing it. While there are letters left, get the last letter and glue it to result, and then make stir one letter smaller. Go from 0 to stir.length minus 1 and update stir that way. So this would also work. Okay, that's pretty good. Oops, that's a pretty good amount of stuff to cover in the lesson today. So I'll pause it there, and we'll get some more practice with while loops in class. But hopefully this gave you a feel for some of the things that you might do with while loops, some of the problems you might solve where you accumulate a sum, or you count things and keep track of the smallest or the biggest, or for example reversing a string if that's something you want to do. Then you can use while loops to accomplish all this. Alright, so I'll see you guys tomorrow in class.